Hello. I'm back again with another useful and interesting topic only for you. We have seen that this chapter is all about surface area and volume of different 3D shapes. And to calculate the surface area and volume of a 3D shape, it's imperative that we understand how a shape is formed and what are its different parts. The shape that we are discussing today is a cylinder. Not just any cylinder, a right circular cylinder. We have already discussed how to find its surface area, and today we will explore how to find its volume. The best part, you already have the basics set for this one. So get ready, new concepts are coming your way. To begin with, let us see how we can form a cylinder. Well, it could be done by stacking up identical discs one on top of the other like this. Pretty similar to how a stack of rectangular sheets looks like a cuboid and a stack of square post-its looks like a cube. Well, there's another way of forming a cylinder by extending a disc along the third dimension like we did in case of cuboids and cubes. Now, if you notice, in each of these cases, the axis or the line joining the centers of the bases is perpendicular or at right angles to each of the bases. So, what do we call such a cylinder? Correct, a right circular cylinder. However, if the discs are not stacked perpendicularly or the base disc is not extended perpendicular to its surface, the cylinders so formed are not right circular because the axis in each of these cases is not at right angles with the respective bases. So, do you remember what we call such cylinders? Don't remember? Well, I taught you, but try to remember this time. They are called oblique circular cylinders. Now, we have already discussed a general formula for finding the volume of a 3D shape that's found by extending a 2D shape perpendicularly, right? So, what was that general formula? Let me give you a hint. It had something to do with the area of the base. Still don't get it? No worries. Try to visualize the concept so you can remember it later. We took a rectangle and extended it by a certain length perpendicularly, and we got a cuboid. So, just by multiplying the area of the base, which is L into B, with the height with which it got extended, which is taken as h, we got its volume L into B into h. Quite similarly, we took a square and extended it by the same length as its sides, and we got a cube. So here again, the volume is just the product of the base area and the height with which it got extended. So, s squared into s gives us s cubed. So basically, the volume of a 3D shape that can be found by extending a 2D shape perpendicularly is equal to the area of the base multiplied by the height with which it got extended. Now, applying the same to a right circular cylinder, all we need to find is the area of the base disc and the height of the cylinder, which is represented by the length of the axis. So, two prerequisites, the area of the base disc and the height of the cylinder. Now, what do we need to find the area of a disc? Its radius, right? So, if the radius of the base is taken as r, then its area would just be pi r squared, and the volume of the right circular cylinder would be pi r squared into h, or simply pi r squared h. How difficult was that? Remember the concept and you shall be able to derive the formula just like this. And now that we have derived the formula, we can see that the actual prerequisites are just the radius of the base and the height of the cylinder, also the value of pi, which is generally taken as 22/7. Something off topic, have you seen the pillars of Ashoka? Well, if you haven't, you really must. The most famous one is in Sarnath. There's one in Allahabad or Prayagraj as we call it today. There's one more in Vaishali, Bihar. And then there are many more spread all across our country. It's so fascinating to know that these structures are as old as the 3rd century BC, when the Mauryan king Ashoka had them erected all over his kingdom. Now, you would be shocked to know that most of these structures are monolithic. That is to say, they have been carved out of a single stone. Imagine being able to calculate the volume of such cylindrical figures with such accuracy without the sophistication of today's technology. I mean, hats off to our ancestors to be able to pull off such amazing mechanical marvels. It's time we take a hint from the works of our ancestors and apply what we have learned to create something beautiful or to cater to a problem that needs solving. I have one such problem curated just for you. Say you work in an NGO that has taken up the task of making a well for the benefit of the people in a rural area. Now, how many cubic meters of earth must be dug out to make the well 22.5 meters deep and of diameter 7 meters? And what would be the cost of plastering the inner curved surface at rupees 3 per square meter? Quite interesting a question, right? So let us first break it down in simpler words. Firstly, your NGO needs to make a well of certain measurement. What is the shape of a well? A cylinder, right? Not just any cylinder, a right circular cylinder that's hollow inside. And if you think about it, the volume of earth to be dug out to make the well is nothing but the capacity of the cylindrical well. Even the question gives us a subtle hint. It asks us how many cubic meters of earth must be dug out. And what quantity does a cubic meter measure? Of course, volume or capacity. Now, after digging up the well, its inner curved surface has to be plastered and the cost has to be calculated. Now, this cost is directly related to the inner curved surface area of the well, right? So, how do we find the inner curved surface area of the well? Let's just take the well out of the earth to find out. We see that it's a hollow cylinder. So, the inner curved surface area of this cylinder can be found just by cutting the cylinder open like this, resulting in a rectangle. So, the inner curved surface area would be the same as the area of this rectangle, which can very easily be found out just by multiplying these two sides. Now, this side is the same as the height of the cylinder, which is nothing but the depth of the well. And this other side is the same as the circumference of the well. So basically, in this question, we just need to find the capacity of the cylindrical well and also its inner curved surface area. The problem is practically solved, right? All we need to do now is just the calculations. This is what your approach to a problem should be. To solve the problem in the mind first and then just do the calculations. So now, let's get the numbers. We can see that the diameter of the well is given as 7 meters, so its radius would just be 7 by 2 meters. And its depth or height, so to say, is 22.5 meters. Now we know that the capacity of a cylinder or a cylindrical well would just be pi r squared h. That is 22 by 7 into 7 by 2 into 7 by 2 into 22.5. So on simplification, we get 866.25 cubic meters. So the cubic meters of earth to be dug out to make the well is just 866.25. Now, for the inner curved surface area of the well, we know that it's going to be the same as the area of this rectangle, which is nothing but the product of these two sides, right? Now, this side, as already discussed, is the same as the height or the depth of the cylinder. And this other side is the same as the circumference of the cylindrical well. So basically, the inner curved surface area of the well is equal to h into 2 pi r, which can also be written as 2 pi r h. We know that 2 pi RH is the curved surface area of a cylinder, right? So we could have actually used this formula directly. So now, coming to the calculations, the inner curved surface area of the well is equal to 2 into 22 by 7 into 7 by 2 into 22.5. On multiple levels of simplification, we finally arrive at 495 square meters. So basically, the inner curved surface area of the well that has to be plastered is just 495 square meters. Now, the cost of plastering is given as rupees 3 per square meters. So basically, the total cost of plastering the complete inner curved surface is equal to 495 square meters into rupees 3 per square meters. On simplifying, we get rupees 1485. So, summarizing, your NGO needs to dig 866.25 cubic meters of earth to make the well and then invest rupees 1485 to plaster the complete inner curved surface. That was a pretty interesting question, wasn't it? Solving it would in turn solve the problem of water in the rural area. Kudos to you and your NGO. However, this was just one problem. There are many more problems, both practical and theoretical, that need solving. Who better to solve problems than you, the savior? So let's quickly summarize and off you go to solving. So in this video, we learned how to calculate the volume of right circular cylinders. We saw that cylinders can be formed by stacking up identical discs one on top of the other or by extending the base disc along the third dimension. If the discs are not stacked perpendicularly or the base disc is not extended perpendicular to its surface, the cylinders so formed are not right circular. They are oblique circular cylinders. If the discs are stacked perpendicularly or the base disc is extended perpendicular to its surface, the cylinders so formed are right circular cylinders. In a right circular cylinder, the axis is perpendicular or at right angles to each of its bases, and the length of this axis represents the height of the right circular cylinder. The volume of a 3D shape that can be formed by extending a 2D shape perpendicularly is equal to the area of the base multiplied by the height with which it got extended. The volume of a right circular cylinder is equal to pi r squared h. Here, r is the radius of the base and h is the height of the cylinder.